This next unit we're starting is Unit 10, Introduction to Probability. So we're going to talk about some probability. Okay, probability is likelihood of something to happen. Okay, but we're going to get more into that in a second. So let's talk about just a basic topic. Let's talk about a deck of cards. So right now I have a picture of a deck of cards. Okay, a deck of cards we know have 52 cards. We have 4 different suits. Suits are the little symbols that are on there. I have club, spade, hearts, and diamonds. Okay, and then we know we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, and queen. Okay, let's answer some of these questions that follow this picture. So how many kings are in the deck? Well, if I look at my picture of my deck of cards, I notice that my kings are in this last column over here. Well, how many kings do I have? Well, if you guessed, we got 4. Okay, how many aces? My aces are on this side. How many do I get? Again, I have 4. Do we notice a pattern? Okay, last one. How many 3s are in a deck? Well, I'm going to go to my 3 column. This is my 3 columns. How many of those cards do I have? Again, 4. What do you notice? What do you notice about each of the different cards within a deck? Well, based on the numbers that we got, 4, 4, and 4, we notice that each card is present 4 times within a deck. Okay, so each card that I have that is present, I see it at least 4 times in a deck. No more than 4 times in a regular deck of cards. Okay, let's move down. Let's talk about clubs. So clubs are, if I go back up here, clubs are that first row. Almost looks like a clover. How many clubs do I have in a deck? I hope you got 13, because that's what I got. Okay, let's talk about how many hearts do I have. Let's erase this. Let's circle my hearts. My hearts is that third row. How many hearts do I have? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Again, we have 13. Maybe are we seeing a pattern? Just like we did earlier. All right, how many diamonds are in a deck? Let's erase all this stuff. My diamonds are that last row. How many do I have? Hopefully you counted 13 as well, and hopefully we are noticing a pattern. And then lastly, how many spades? Well, I'm sure you guessed it by now. It is also 13. Okay. Well, based on our data, okay, the numbers that we got, 13, 13, 13, 13, we can conclude that each suit, a suit is a club, heart, diamond, and spade, have 13 cards within a deck. So there are 13 clubs, 13 hearts, 13 diamonds, and 13 spades. Okay, let's move down to some probability notes, starting 10.1. So an outcome. Let's talk about some definitions. So an outcome. An outcome is a possible result of an experiment or trial. Okay, so if let's say I had a coin. Well, we know that a coin I can only flip as heads or tails. Well, the outcomes, if I flip a coin, is heads or tails. Okay, so it's the possible results you could get out of an experiment. And then an event. An event is a set of outcomes of an experiment. So let's say I had a coin and I flipped it 3 times. Okay, so let's say the first time I flipped my coin, I got heads. Second time I flipped it, I got heads again. third time I flipped it, I got tails. Well, in this case, my event is heads, heads, tails. Okay, those are the outcomes that I got when I flipped my coin 3 times. That's called an event. And then our whole unit is about probability, and here's that definition. It's a numerical description of how likely an event is to occur. Okay, and we're going to get more into that in a second. We did a little bit of this when we were talking about ratios, proportions, not so much proportions, more so ratios. Okay, let's talk about example 1. So, in a 6-sided die, what is the probability of rolling? We have ABC, a 3, an odd number, or a multiple of 3. Let's talk about a 6-sided die. In a 6-sided die, I know that I have 6 sides. Well, what are those sides? Well, they're numbers. I have 1, 2, 3, 4, 5, and 6. There are 6 sides. Each side has a number. Those numbers are 1 through 6. Okay, so what I want to know is, what is the probability of rolling a 3? Well, how many 3s do I see within my dice? I have 1 here. Well, that's it. I only got 1. So I have 1, 3 on my dice. So then we come up with our ratio. It's the total number of possibilities over my possible outcomes. Okay, let's talk about the total. Well, I have 6 sides, I have 6 numbers, so my total is actually 6. What goes on top is what I'm trying to find, the possible outcomes. What I'm looking for is a 3. Well, I just made note that there is only 1 3 within my deck, so 1 goes on top. So my probability is 1 to 6. So I have 1 to 6. If I were to do this in a calculator, divide 1 divided by 6, I should get 0.17. Leave it as a fraction or a decimal. When I leave it as a decimal, I want 2 decimal places. I'm sorry, 2 places past the decimal. Okay, let's talk about the second one, or B, an odd number. Okay, so I'm going to look at the numbers that I have within my dice. So I have, again, 1, 2, 3, 4, 5, 6 right here. How many odd numbers do I have? Let's go through the list. Well, we know 1's an odd number. I know 3's an odd number. I also know 5's an odd number. 2, 4, and 6 are not odd numbers. So the total possibilities that I have are 3 odd numbers on my dice. So let's set up that fraction. My fraction will always follow this one here. Possible outcomes over my total. Okay, well, I have a total of 6 sides. That's not going to change for this problem. I didn't change what I'm messing with. Okay, I'm just messing with one die. Okay. How many odd numbers did we find? We found 3. 3 goes on top. Okay, again, those are the 1, 3, and 5. We know that those are all odd numbers. Okay, well, can I simplify this fraction? In fact, I can. This actually reduces to 1/2. When I looked at A, 1 over 6 cannot be reduced. But 3 over 6 definitely can, and that one is reduced to 1 over 2. Make sure you are reducing to the, or simplifying your fraction, okay? So my answer is 1/2. Or again, if I were to plug this in my calculator, I get 0.50. 2 decimal places, remember. I'm sorry, 2 places after the decimal. All right, let's talk about the next one. So I want to look for multiples of 3, which means things that can be divided by 3 evenly. So I'm going to erase what I have here. Okay. Well, 1 divided by 3 does not give me a nice neat number. 2 divided by 3 does not give me a nice neat number. 3 divided by 3 does give me 1, and that is a nice neat number. So there's one of them. Let's talk about 4. 4 divided by 3, not a nice neat number. 5 divided by 3, not a nice neat number. And then 6 divided by 3, which gives me 2, that is a nice neat number. So in this case, now I have 2 multiples of 3 on my dice. Okay, again, we're following that ratio that we set up earlier, possible over total. My total is, again, 6. Well, how many options do I have in this case now? 2, which I just found here. Does that fraction simplify? In fact, it does. I get 1/3. So my answer is 1/3. Or if I were to put that in my calculator, I should get 0.33. 0.33. All right, let's move on. Let's talk about example 2. In a standard deck of cards, what is the probability of choosing a king, an ace of spades, a red card, or a diamond? Okay, so standard deck of cards. Well, if I go back to what I looked at earlier, how many total cards do I have in a deck of cards? Take a minute. You can count the picture above. How many cards do I have? I should have gotten 52 total cards. Okay, so again, my total is 52. We want to find the probability of a king. Well, how many kings do I have in a deck? Again, if we go back and count, which we actually already did this, we only have 4 kings within a deck. Okay, so again, I can set up my fraction. My total goes on the bottom. My total is 52. The possibilities of having a king, is 4. Okay, well, can I reduce this? Absolutely. I get 1/13, which is my answer. If I plug it into my calculator, I should get 0.08. That is the probability of drawing a king. Let's talk about the ace of spades. Well, how many ace of spades are there? We're looking for an ace, and it's got to have the suit of a spade. This is actually only one option. Okay, so then I can set up my proportion again. I have 1 is the amount that I could possibly have over my total, 52. In this case, I cannot simplify. So that is actually my answer. Again, if I plug it into my calculator, I get 0.02. All right, let's talk about a red card. A red card. Okay, well, how many red cards do I have in a deck? I'm going to give you a second. Go ahead and count. How many do I have? If you counted, you should have got 26 red cards. Okay, these consist of my hearts and my diamonds. All right, let's set up my ratio. So again, my total is 52. I have 26 red cards. Can I reduce this fraction? Absolutely I can. I get 1/2, which is my answer. If I plug that into my calculator, I should get 0.50. So half of the time, I would be getting red cards if I were to pick at random. Okay? All right, and then my last one, a diamond. Well, how many diamonds do I have in a deck? We also counted this one as well. We counted 13 diamonds. Remember from earlier, we had 13 of each suit. Okay? Again, we can set up my ratio, 52 on the bottom, that's my total. 13 is the total possibilities. I can reduce this fraction to 1 over 4. I have 1 over 4, which if I plug in my calculator, gives me 0.25 as my answer. Let's talk about example 3. So in a random group of students, there are 6 freshmen, 8 sophomores, 4 juniors, and 10 seniors. Okay. First, in order to solve for a probability, I need the total amount of possibilities I could have. Well, what's the total? How do I get the total? If I have 6 freshmen, 8 sophomores, 4 juniors, and 10 seniors. Well, to find the total, all I'm doing is adding up those numbers. So I'm adding 6, 8, 4, and 10. When you add them all up, you should get 28 total students. Okay, well, what is the probability of randomly drawing or choosing a junior? Okay, so again, I'm going to have my ratio. The total goes on the bottom. My total is 28. Well, how many juniors do I have within this sample? I have 4, so 4 goes on top. Okay, I can reduce this fraction. I get 1 over 7. 1 over 7 is my answer, which also, if I put it in a calculator, becomes 0.14. Okay. All right, let's talk about B. Randomly choosing a senior. Again, I need my ratio. 28 is my total. Well, how many seniors do I have? I have 10. So 10 goes on top. I can reduce this. This is 5 over 14. 5 over 14 is my answer, or 0.36 if I plug that into my calculator. All right, last one. Randomly choosing a freshman or a sophomore. Okay, so this one gets a little bit trickier. So again, my 28 goes on the bottom because that's my total. That doesn't change. I didn't change my sample size. Okay, but randomly choosing a freshman or a sophomore. So in this case, I'm looking at freshmen and sophomores. Okay, well, how many of those do I have combined? How do I find that? Well, to find it, I'd simply add them. Add my 6 and my 8. I should get 14. Which means if I were to have a class size of 28 with these exact numbers, okay, if I can reduce this, I get 1/2. There is a 50% chance of me choosing a freshman or a sophomore. And our last one. All right, I got some colors here. I have red, yellow, and blue. Each of them are a third of my circle or diagram. Okay, how many options do I have in total? Because that's what I need first. In order to start any of this, I need a total amount. Well, how many colors do I have? 3. So my total, I have 3 options. What's the probability of spinning a red? All right, so I need my little fraction bar. The total goes on the bottom. Out of the 3 parts that I have, how many of them, in this case it tells me, how many is red? How many parts of it? In this case, I see 1/3 as my red part. Can't reduce that, but I can put it into my calculator. I should get 0.33. All right, let's talk about spinning a yellow. Okay, well, my total goes on the bottom. My yellow is that part there. There's only one part that I have out of those 3 parts. Again, I can't reduce, plug it into my calculator. I should get the same 0.33. Next one gets a little more tricky. Okay, the probability that I do not spin a blue. Okay, so blue is out of the question. but I can spin any other color other than blue. Well, I have red and yellow. I'm going to set up my fraction. 3 goes on the bottom because that's always my total. Okay. Well, there's 1 part red, 1 part yellow. How many parts does that make? In this case, 2 parts. Again, 1 part red, 1 part yellow. Add that together, I get 2 parts. I cannot reduce this, but I can plug this into my calculator. I should get 0.67. And then lastly, spinning a primary color. Primary color. Well, if we remember back from way back when, art class, my primary colors are red, yellow, and blue. Well, those are the exact options that I have. So actually, this is 3 over, well, this is a primary, this is a primary, and that is also a primary. I have 3 options. Over 3, this is actually 0.1. I'm sorry, 1.00. So 100% of the time, I will spin a primary color. Okay, this is an introduction to probability.